In this video, I will teach you how to use periodic functions to model situations in the real world. In this case, a rider boards a Ferris wheel 10 feet, 10 feet above the ground level. The diameter of the Ferris wheel is 50 feet, and the wheel completes one full rotation every 24 seconds. Which graph represents the relationship between time and the height off the ground? So we have several graphs to choose from, and we have to pick the one that matches the story. Okay, a couple of things. For example, you need to understand what the word diameter means to be able to do this problem. So hopefully you remember easily from geometry class that when we talk about a circle, let's draw a circle. Let's do whatever this color is. Okay, so when we talk about a circle, the diameter is the distance from one side of the circle all the way to the other. So this red line that I'm drawing, that is the diameter. And we're saying that this is, what did they say, 50? The diameter is 50 feet. Okay, so this whole thing is 50. But guess what? That is not what actually matters here. Now, you know what? That's fine. I'll stick with this for now. So understand something else. This is a Ferris wheel. It is rotating around and around. Okay, and as it rotates, a person that was riding on this Ferris wheel is going to go up in the air and go back down again. And they're going to go back up and they're going to go back down. So if you're just graphing the height of the person over time, you're going to get a graph like this as the person goes up in the air and back down again, and up in the air and back down again. All right, so we're going to look for a couple of things. First of all, the rider boards a Ferris wheel 10 feet off the ground. Okay, so the rider boards the Ferris wheel obviously at the bottom. So you're supposed to imagine that there's some sort of platform or something here where people can, board the Ferris wheel at the bottom. And the platform is 10 feet off the ground. So I got an extra 10 feet right here. So only a graph that starts low and then goes high is going to make sense. People are boarding at the bottom of the Ferris wheel and then they go up. So this graph looks good in that sense. But for example, I can throw out this one because no one's going to board this Ferris wheel 60 feet in the air. That's not happening. Okay, they're boarding at the 10-foot level, way down at the bottom, and then they go up. Are there any other graphs we can throw out? Well, we cannot throw this graph out because they are boarding down low at the 10-foot level and going up, so that's plausible. We can throw this graph out. Again, we are not boarding at the top of a Ferris wheel. That's not the way this scenario works. So we can throw this one out. So we've narrowed it down to this one and this one. So let's go a little bit deeper. We know that the diameter of the Ferris wheel is 50 feet. So that means we should be able to check the graph and see, is it 50 feet from here to here, from high to low? Is this 50 feet? Well, up here at the top, this is 60 because it's right here between 55 and 65, so that is 60. Down here at the bottom, that's the 10 that we were talking about. 10 to 60. That is 50 feet. So that matches. If the other one doesn't match, then we have a winner. Well, let's see. This one, well, it's the exact same thing. This is 60 up high, and it is 10 down low. All right, diameter of 50. So we cannot rule it out based on that. So there's one more piece of information that we can use, that we're going to have to use. They told us that the wheel completes one full rotation every 24 seconds. Now I glance down here and I don't see, these are decimals. So this must be minutes. So let's convert 24 seconds into minutes. So a little quick unit conversion. If I have 24 seconds, if I want to convert that to minutes, I know that 1 minute is equal to 60 seconds. And I set it up this way because I know I need the seconds to cancel out, leaving only minutes behind. So really, this comes down to 24 divided by 60. And that is 0.4. Okay, so 24 seconds is the same thing as 0.4 minutes. So one cycle of this graph is like this. That represents one rotation of the wheel. So let's look and see how many minutes that was. Oh, look, boom, 0.4. I think we have a winner. But just to be sure, let's go ahead and check the other one. Okay, so here's one cycle of this graph, like this. And that's way over here at 0.8. No. You are a loser. So let's go back and reveal the winning graph. This one should be the answer. So if I uncover this, I should see a check mark. Kabam! We got it.